Okay, so we're going to talk about the atom and subatomic particles. So atoms are made up of 3 subatomic particles. They are made up of protons, neutrons, and electrons. So we're going to take a few minutes and talk about each of these types of subatomic particles, where they're found within the atom, and how we represent them in different types of shorthand notation. So protons are positively charged. Sometimes you'll see protons referred to as P with a little plus sign up as a superscript because it's positively charged. Neutrons are neutral, they have no charge. And sometimes you'll see neutrons written with a lowercase n and then like a little 0 sign up here because there's no charge. And then the last, electrons, these are negatively charged. And they are represented as E with a negative sign. So these are the 3 subatomic particles. And 2 of these subatomic particles, protons and neutrons, are located in the nucleus of an atom, and the electrons are orbiting an atom. So you may have learned about an atom in what's called the planetary model, where you would have the nucleus of an atom and then kind of what looks like the planets orbiting the sun, these rings of concentric circles around an atom. This is not what an atom actually looks like, this planetary model. It does show us kind of where things are spatially, but electrons do not orbit the nucleus in these concentric rings like this. And we're going to talk about all of this a lot more later, but this just might be something you've learned before. So in the nucleus, we have protons, positively charged protons, and neutrally charged neutrons. And then orbiting the nucleus, we have electrons orbiting the nucleus in these shells. So we're going to spend a lot of time on this later. What you need to know about an atom right now is that protons are found in the nucleus, neutrons are found in the nucleus, and electrons are not in the nucleus, they are orbiting the nucleus. And they are not orbiting the nucleus like this, like the planets orbit the sun. This is just kind of the simplest model of subatomic particles to show their location. Protons and neutrons in the nucleus and electrons orbiting the nucleus. So let's talk about what these subatomic particles mean when we are talking about an atom. So one thing that's important, and really important characteristic of an atom, is its atomic mass. The atomic mass is just the mass of the atom. The atomic mass of an atom is the sum of the protons and neutrons. It's not the sum of the protons, neutrons, and the electrons because the mass of an electron is negligible. And what negligible means is that it's so small that we assume it's 0. Now it's not really 0, but it's about 2,000 times smaller or less, has about 2,000 times less mass than a proton or a neutron. So when you're adding the subatomic particles, the atomic mass is really just due to the mass of the protons and neutrons, because the mass of an electron is so small that it's negligible. So we say that the mass of a proton or a neutron is what's called an AMU. It's an atomic mass unit. It also, 1 AMU equals 1 what's called a Dalton. Sorry, that's DA, which is another unit that we use, especially in biochemistry when we're talking about mass of atoms. And the mass of an atom is just the sum of the protons and the neutrons. So we're going to also introduce something that's called a nuclide. And a nuclide is a shorthand symbol that we use to tell how many protons, neutrons, and electrons we have in an element. So this is an example of a nuclide, and then we'll do some other examples. So we have X, which would be the elemental symbol. This would come from the periodic table. And then we have A up here, and what A up here is the mass number. The mass number is the atomic mass. Mass number equals atomic mass, which we said was the sum of protons plus neutrons, or neutrons plus protons. Down here we have what we call Z. This is what's called the atomic number. The atomic number is just the number of protons. This is what gives an atom its identity. Okay, so we have atomic number, which is just the number of protons, mass number or atomic mass, which is protons plus neutrons, and then the elemental symbol, which is here from the periodic table. So the elemental symbol here from the periodic table, this is important. It's always 1 or 2 letters. The first letter is always capitalized. The second letter, if there are 2 letters, is lowercase. And this is important because if you put 2 uppercase letters, then you're no longer talking about an element on the periodic table. You would be talking about a molecule or compound of multiple things combined. So for example, C on the periodic table is carbon. O on the C, capital C, lowercase o, this is cobalt. Capital C, capital O, this is a lowercase o. Capital C, capital O is carbon monoxide. Carbon and cobalt, these are both elements on the periodic table. Carbon monoxide, this is a covalent molecule. It's a type of compound. So if you are not paying attention to the second letter, or the uppercase or lowercase, it could mean a totally different thing. So if it is an element and there's 2 letters in it, make sure the first letter is uppercase and the second letter is lowercase. Okay, so let's look at an example. Let's do carbon from the periodic table. So carbon is letter C on the periodic table. It's number 6, so that means it has 6 protons. And I'm telling you that the mass of this carbon is 12. If you look at the periodic table, it says 12.01. That's what's called an average atomic mass, and we'll talk about that later. We're just going to put a 12 up here. So now this tells us how many protons, neutrons, and electrons are in this atom. So the atomic number is always the number of protons. Atomic number equals number of protons. So that means I have 6 protons. So this is an atom, and one thing that I haven't mentioned yet is that atoms are always charge neutral. Which is to say that the number of protons always equals the number of electrons. The number of positive charges always equals the number of negative charges in an atom. So if this is the carbon atom and the atomic number is 6, that means the number of electrons also has to equal 6. 6 protons, 6 electrons. Up here we see the mass number equals 12. Well, we know that 12 is the number of protons plus neutrons. I know that I have 6 protons, so that means protons plus neutrons equals 12. So that means the number of neutrons has to also equal 6 neutrons. So this is kind of a weird example where protons, neutrons, and electrons always are all 6. This is not the way it always is. This just happened to be this way. So this nuclide right here of carbon tells me that the atomic mass, the mass number is 12, which is the number of protons plus neutrons. The atomic number is 6. So you could figure out the number of neutrons by subtracting the atomic number from the mass number. And then because this is an atom, the number of protons always equals the number of electrons. So I said atoms are always charge neutral. So there are two other things that we're going to talk about. Not in this, well, ions we won't talk about in this chapter. Maybe a little bit. But what an ion is, ions are charged, which means number of protons does not equal the number of electrons. You either have more or less protons or electrons, so ions are charged. We're not talking about ions here, we're just talking about atoms, but maybe you know of some cases where the protons and electrons don't always equal each other. Something else that we are going to talk about are something called isotopes. So an isotope is 2 atoms with the same number of protons but different number of neutrons. So you could have isotopes of each other where you could have carbon that has an atomic mass of 12, and then you could have carbon that has an atomic mass of 13. So the carbon with an atomic mass of 12 has 6 protons and 6 neutrons. Carbon with an atomic mass of 13 would have 6 protons but 7 neutrons. So carbon 12 and carbon 13 would be isotopes of each other. So we'll talk about isotopes a little more later, but this is what you need to know, the foundation for this chapter about atoms and their subatomic particles.